Right, one of the first things we want to do quite often in terms of vectors is basically split a line and find a single point on that line, given a ratio, okay? So you may be told that a point divides a line connecting two other points in a ratio A to B, okay? Obviously A and B being numbers, and we obviously want to find exactly where that point is. Whoa. So we've got the points A and B, and then we've got C somewhere along that line, and we're told it's split in a ratio. So this is obviously, hopefully you can see this is a ratio 3 to 1. We've got 3 parts on the left of C, and we've got 1 part on the right of C, okay? So the line AB above has been divided by the point C in a ratio of 3 to 1, but this is not to be confused with being divided into a third, okay? We need to think about how many parts there are there. If there's 3 parts on one side, 1 part on the other side, this is split into 4 parts, and it's 3 along from the first letter in our vector, okay? So just be careful with how you read a question like that. Okay, so the same line could be split by another point D in a ratio 1 to 3, and that would be over this side. So as I say, if it was split in a ratio 1 to 3, it's 1 part from the first letter. So if we're given the line AB, we're obviously starting, because obviously it's a vector, and the vector goes from AB. I've maybe not made that clear enough, but it's the same idea with vectors, okay, and the same idea with lines. It's 1 part from the first part, and then a further 3 parts to the second letter, okay? So what is the ratio in which R splits the line PQ here? Obviously, we can see that there's 5 parts there, and R is splitting the line PQ with 1 part on one side, 4 parts on the other side, in which case it's splitting in the ratio 1 to 4. If there was a point here, for example, let's call this X, that would be splitting the line PQ in the ratio 3 to 2. Okay, right, so here's an example. A is the point 4, 4 minus 3, and B is the point 4 minus 6, 12. P divides AB in a ratio 3 to 2. Find the coordinates of P. Okay, so it often helps to draw a diagram with something like this first. It doesn't have to be neat, okay? It's just kind of giving you an interpretation of what's going on here. So if it's 3 parts and 2 parts, there's a total of 5 parts that kind of we're splitting the line AB into, okay? Right, I'm going to go through this in the long method. There is a much, much shorter method that you can use as long as you kind of arithmetically able, okay? Arithmetically. In order to split the vector AB, we first need to write it in component form. So this is where we bring vectors in, because we've just got points. And if we're going to do this in terms of splitting it, we need to know something about this line in terms of lengths. That's what a ratio is at the end of the day. Okay, if it's splitting into parts, it's splitting into lengths. So we need to convert these coordinates basically into something to do with vectors. So what we can do with this, in the same way as we were looking at before, if we're trying to find the vector AB, then it's B minus A. Remember, this is to do with position vectors, and if we've got coordinates, we need to change them into position vectors before we can find the vector AB. Okay, so it's B minus A every single time, in which case it's the position vector of B, which is 4 minus 6, 12 vertically, minus the position vector of A, which is 4, 4 minus 3. And when we're doing this, it's just a case of taking away the first components, taking away the second components, taking away the third components, and just be very, very careful with negatives. 4 minus 4 is 0, minus 6 minus 4 is minus 10, 12 minus 3 is 12 plus 3, which is 15. Okay, so now we've got the vector AB. What we're trying to think of now is how far along that vector AB point P is from A, okay? It's basically 3 parts of the total of 5. So it's 3/5 of the way along, okay? So now that we've got the vector AB, we can find 3/5 of the vector AB, in which case basically what we're doing is we're finding the vector AP. So 3/5 of 0 minus 10, 15, divide by the bottom, times by the top, leaves us with 0 for the first one. A fifth of minus 10 is minus 2, times by 3 is minus 6. A fifth of 15 is 3, times by 3 is 9. This gives us the vector AP. Now basically what we can do is we can take the vector AP. This isn't our answer, and this is where a lot of people get confused. This just gives us the distance that P is from A. So now if we're going to find the point of P, what we've basically got a situation, and I'll try and draw this from here, is we've got A, we've got P, okay, we've got the vector AP, and now what we want to do is we want to find the coordinate of P. So given we've got the position vector of A, what that means, okay, is we know the kind of the vector from 0, and now we know the vector AP as well. So if we're going to try and find P, we can find the position vector of P by using vector pathways and going from basically 0 to A, in other words, the position vector of A, and then from A to P using the vector that we've just found. Add them both together, and then we'll find the position vector of P, and if we have the position vector of P, we can find the coordinate of P. So taking the 4, 4 minus 3, in other words, the position vector A, adding on the vector AP, and then it gives us the position vector. And this is where you got to be careful. We're asking the question for the coordinates of P, but the coordinates are literally 4, minus 2, and 6. So make sure you make that change at the end. Okay, right, we could have done this much easier if we just thought about the numbers. So again, you have to think about the ratio. We've got 3/5, and it's basically 3/5 of the distance between the x values, the 3/5 of the distance between the y values, and 3/5 of the distance between the z values. So if you're going from 4 to 4, okay, you're changing no distance in the x direction anyway. Okay, that's why it was 4 in the answer. Okay, if we're going from 4 to minus 6, okay, and just think in terms of a thermometer or something, that's basically a difference of minus 10. 3/5 of that difference, okay, and this is in theory what we're doing down here, we're just doing it without using vectors. 3/5 of minus 10 is just minus 6, and minus 6 from 4 is minus 2, and that gives us the second number. And then in the same way, we can go from minus 3 to 12 in the z direction. Minus 3 to 12 is a difference of 15, and we basically want 3/5 of that distance. 1/5 of 15 is just 3, 3/5 is 9, so we want to go 9 on from minus 9, which takes us to 6. So there's nothing wrong with doing that, okay? And it's actually one of the reasons why they don't ask you many of these questions in tests and exams anymore, because there is a quite straightforward way of doing it. If you're nice and confident, then you can do it like this. If you feel like you need a bit more time and want to be a bit more sure of yourself using vectors, then you can do it the first method. It's entirely up to you. Both ways will give you full marks for the answer, okay? Right, so this brings us kind of a little bit further to vector pathways. This is the kind of stuff you looked at in National 5, okay? And you've just got to be careful in instances like this, okay? If I look at this second one, for example, and this is one where it often gets confused. We have vector A, okay? In which case we could have any of these parallel lines, okay? So we have all of these vectors, in which case I know basically how to get along any of those lines. I also have vector B, okay? In which case I have all of the lines parallel to this. In other words, I don't know this vector, and I don't know these vectors either. Okay, so I can't basically, they're forbidden. I can't go down those lines. If I want to get anywhere around this, I basically have to go along lines I do have. I can't go along any of them. Okay, it's the same kind of idea in higher. Okay, obviously we're just making it a little bit more complicated and adding in some ratio as well. So A, B, C, D, E, F is a triangular prism with a rectangular base A, B, C, D. M is the point that divides A, B in the ratio 1 to 2. So you most often get a diagram with this, which kind of explains it pretty clearly. But if we've got point M there, then obviously it divides it A, B in the ratio 1 to 2, in which case there's 3 parts there. 1 part between A and M, 2 parts between M and B. Okay, so just get that right in your head, draw it on a diagram, entirely up to you. What we want to do here, given these vectors, is express the vector FB. Okay, so we're going from F to B in component form. Right, we've got to think of this as a journey. We can go any which way around this as long as we know the kind of correct components. So what we have is we have EC. So I have this vector here, okay? In which case, I also know this one over here. I know from F to D, but nothing else is parallel with that. Okay, I can go from E to C, I can go from C to E because I know the negative, but I can do the same with F and D, but at the moment, ignoring the rest, I don't have anything else. Okay, I have AD, in which case I have that vector, which means I have this vector because it's parallel. So there's a little bit of knowledge of triangular prisms here, but they're both parallel, so I have both of them. I have both of those journeys, hunky-dory. Right, I also have AM. And the idea of AM is that obviously I can use it to find the whole distance from A to B, and I can use it on the other side to get from D to C, and I can get from F to E. In other words, I don't have anything at the moment to get me directly from F to A, or from E to B, or obviously either of those paths in reverse. So I've got to kind of go around. In other words, if I'm trying to get from F to B, so if I'm trying to get from all the way up here to all the way down here, I'm going to have to follow this route from F to D, and then I can go from D to C, but I'm probably going to come across here first and then all the way across here, okay? Right, which basically means that if I'm going to do this, have I done this right? F to D plus D, no, I've done it the other way around. So I've gone across here, it doesn't really make any difference, but I've gone from F to D, and then to D, from D to C, and then from C to B, okay? bottom line is I can't go from F to A or E to B. It doesn't really matter how I do this. It's going to work out either way. If I'd done it how I did it, drew it in the first instance, that would be fine as well. But you have to write this down, okay? When we're marking this, we have to mark it based on a pathway that you've created, and you have to make it clear which pathway you're using, okay? Right, so equivalent to what we actually have. So I don't actually have FD, but I have EC, okay? So these two things are exactly the same. I don't have DC, but I have AM, and I know because the point M is splitting the vector AB into thirds, I know that if I have 3 of my AMs, I can get from D to C. So they're the same. And then from C to B, I don't have C to B, but I have A to D, and which is equivalent, or C to B is equivalent to minus AD, okay? So try and write these two things as much as anything else to get the marks, but also to kind of direct you into what you're doing. Now it's just a case of getting the correct vectors for these. Okay, I know EC, so that one's easy. I know AM, I just want to times it by 3, and then I know minus AD is just AD, but all the symbols changed. Okay, and once I've kind of multiplied this through, it's easy enough to work out what FB is. Okay, so 3 times by 4 minus 6 and minus 2 is going to give me 12, minus 18 and minus 6. And when I add all those things together, I get the vector FB, which is 16 minus 22 minus 1. It's asking me for the vector FB in component form, so don't try changing this to coordinates or anything. It doesn't really make sense anyway. It's not a coordinate. It's a vector from F to B. That's what I'm asked for. We're absolutely fine there.